Hey everybody, welcome back to the Chili Pork Unit. I am Chili. Last video, I introduced you guys to the ASS, which is of course the Chili Pork Unit assembler. And today, we're going to do some work on the Chili Pork Unit itself, because after all, that's what this series is all about. So what are we going to do? Well, if we look at the assembly program that I had, let me just bring it up here. I'll bring it up from the Google Sheets. There's an annoying thing that we have to do every time we want to load something, load a variable from memory into a register. First, we have to load the address, and then we have to indirect load into the register. And this is annoying. I don't like this. So I want to be able to just, I think I said so in the end of the last video, but I want to be able to do something like this, or maybe even something better. But you know, I want to have just I don't have to have this instruction here. Just load directly from memory into the register using an immediate value for the address, instead of having to load the immediate value and then indirect load from memory. That's what I want to be able to do. So that's the goal. It might take a few videos, it might take one video, but the first thing we're going to do, before we do that, I want a no-op instruction for a number of reasons. When I start to play around with programs, replacing instructions with new ones, new better ones, I like the ability to be able to fill in the gaps, right? Because like, if I were to make that instruction, this thing would no longer be necessary. And instead of having to recompile the entire program while I'm, researching and developing, I'd like to be able to just replace this with a no-op, and then the whole program would run as expected. So let's make ourselves a no-op. I mean, it would be nice if we had a natural no-op, like for example, ORing a register with itself. We don't have that yet. So let's make a no-op instruction. So I guess the first step would be a little bit of planning here, maybe. Let's allocate for a no-op. And the opcode, I guess we're going to have to open up a new opcode domain. Maybe it would be 00101. Is, I suppose, possible? Yeah, I think we've got zeros, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1 is the next one. Now, opcode doesn't actually require parameter bits. Oh, wait a minute here. This is weird. N. What is N? All right, N is the not bit. I guess it allows you to do like the jump not equal, jump not above, jump not below. So that's not necessary for JMP, right? So it's just fixed to 0. So what we can do is, that means that there is one opcode that's basically free here. So if I do 1, 1, 1, this could be no op, right? That makes sense, because that's not going to be used by this, and it's not, obviously it's not this. So that's open. We can reclaim that. We don't have to open up a new domain. Okay, that's fine. We just got to make sure that this isn't triggered by this. And I don't believe it is. This should be the not bit. And we can see here that it has to be 0 for this to be triggered. And none of these other ones will be triggered. So, but the instruction as a whole might actually be triggered. That's a problem. That could be a problem. Like, this might be enabled, right? Now, I suppose I could put some, logic into here. Or maybe pipe some logic from here into here. Yeah, somehow make sure so that that particular bit pattern does not activate this instruction cell. But, you know what? I don't care. I'm not feeling it. We can scrimp and save and reuse this instruction opcode somewhere else. But I'm sure we're going to need a bunch of random opcodes anyways. So it's okay to open up a new domain here. Yeah, 101.0.0.0 here. And we won't worry about trying to fit it into the empty space here. But if we need it, we've got an additional free single opcode that we could reclaim from here. We just have to do a little extra work to make sure that this doesn't get activated. All right, now for the fun part, figuring out the control bits on this bad boy. All right. Load memory. Probably be 1 because I believe if it's 0, then we're storing into memory, which would be bad. NOP should not change anything about the state of the machine. So, yeah, this one, select address. That's probably going to be a big old don't care. Let's just put 101 because the other don't cares have that, and that seems it seems good to me. I'll put the colors on later. I don't remember how to do it. Increment instruction pointer. So I believe this would basically enable it to be incremented twice, both in the first half and the second half of the clock. And that's for things where you have to load an immediate value maybe, but move register to register also has it at 1. But move here to here doesn't have it. I'm a little confused. Maybe these are out of date or something. I should look into that actually. I can see, I'm pretty sure it's definitely required for anything with immediate. But for non-immediate things, I don't see why we have to have the increment IP enabled. I'm going to put it at 0. All right, what's this one? Load instruction pointer. I mean, definitely not, right? Enable F. Probably not. Could be a don't care as well. So increment IP, that's not a don't care. That is a do care. This one was a don't care. Yeah, okay. Who else? Who else don't we care about? Load instruction pointer, definitely care about that one. Enable F. We might not care about that one. It probably doesn't matter, but let's just, let's be thorough here. Let's document if something is don't care or not. So I guess enable F is this one here. Do we care if this goes on to the D bus? I mean, I highly doubt it. I guess the only issue is that, you know, the D bus might be driven by both the ALU and the memory, but if it is, do we care? We're not loading into this latch. We're not loading into either of these registers, so it shouldn't matter. So we're gonna say it's a don't care. That's right, yeah. Enable flag. Definitely don't want to enable any of the flags. ALU operation. This is a don't care, right? I feel like this should be a don't care. I don't see. Let's put 001 because everything else seems to be that, right? But I don't see. What is 000, by the way? Just for subtraction. Ah, I see. Okay, well. Don't think it matters. What do we got here? Select X, select Y. Again, this doesn't matter. So let's just do 000, 000. And those are just two big old don't cares. Enable A, enable B is definitely a big 0 and 0. This is, I believe this is for loading into A and loading into B. So we definitely don't want to load. It seems all right though. All right, so lots of zeros here. You know what? Since this is a don't care, I'm going to put this as 0. It'll just make my life easier. If this is truly a don't care, then this should also be able to be set to 0. And that means we only have to set bit 20, and the rest can all be 0. And it should work. So, going back to the opcode. 1011, so this is 8. And this is 2, so 28. That is our no-op opcode. All right, now how do I copy lots of things? Maybe like this? Nope. Well, it says copy selection. Let's try that. Can I paste? Sort of. Seems to be working. Okay. All right, so. Probably want to give more space. I mean, no-op is going to be very simple, so we don't have to give that much space. But we got to give some space. Can I please make a... Yeah. No. Now we zoom in. Then we fight with the user interface. We connect this. Okay. All right. So, I want this and to have how many bits? Number of inputs, we want 8. Yes, that seems good to me. I'm going to zoom in even more. Give me all the zoom. Zoom, zoom, zoom. Okay, now we have to figure out which ones are negated and which ones are not negated. So it's time to brain. So if it is 0, we should negate. If it is, the glove does not fit, you must quit. Is I believe how it works. So we want 0, 0, 0, 1, 0, 1. Just top, bottom. 0, 0, 0, 1, 0. Wait, no. Ah, this is 8. Okay, 1. Okay, 0, 0, 0, 1, 0, 1, 0, 0. This works, right? Yeah. Yeah, that's gonna work. Okay. Now, this bad boy needs more. Needs more. 0, 1, 2, 3. Okay. We need fan 08. 0, 1, 2, 3, 4, 5, 6. Oh, it did it. Okay, well, just change the fan out and you'll automatically get all that. Good to know. Why do these not match up? Why do these not match up? Okay. Come on. Ah, because there's a freaking... why did you put this? You're making me so crazy. Okay, wait a minute. If I put a number of inputs to 9... No, that's not going to work. That's not going to work, Chili. Okay, well, we almost could just go straight through. But because we can't have nice things, therefore, we got to do this. No, stop it. No, what did I say? I said stop it. There we go. Okay, so step 1 completed. We have our decoder, our opcoder, decoder. Excellent. Let us now again zoom out. Okay, so I don't really know what this is for. What is this line? What does it do? I mean, every instruction seems to have it, so it seems important. I guess somebody's got to drive this. This is the thing that says whether or not there's a phase 2. So this will become important when we implement the immediate indirect movement. But for right now, we just do as we've always done, and we pull it up. Okay, so how do I do this in the laziest way possible? Let's just copy a bunch of stuff. Yeah. Copy that. Now what if I were to paste that here? Well, I didn't go there. I went down here. But I cannot scroll by dragging. Okay. Okay, so we're going to stretch this up. And what we're doing, that's not a stretch. That's not a stretch. That's a stretch. Okay. Okay, so one of these guys, the pull-up boy goes to the close one. That's you. Mission accomplished. And you go there. To the far boy. All right. So, these boys are going to be coming in from here. All right, looking good. Got rid of the red. We got rid of the reddies. Now this should be rather easy. Why? Because all the numbers are fixed. There's nothing calculated here. There's gotta be, what is the shortcut to zoom in? There has got to be a shortcut to zoom in. There's no way that there's no freaking shortcut. I gotta learn that if it exists. Okay. So we just connect this here. Connect this here. And then hexadecimal. I like hexadecimal. What is the... don't do that. Just change the value. 1. No, please don't deselect for no reason. Thank you. 0, 0, 0, 0, 0. Is that good? Yeah. I think that's the same number of digits, right? 5 zeros. And there are 5 digits there. So the top, only the top bit, the bit 20. Is that bit 20? 5 bits. So this would be 4, 4, 4, 4, 4. 16, that's 20 bits. This would be bit 21, which is bit 20, right? Because 19 is the 20th bit. So 20 is the 21st bit. That's here. Okay, so that makes sense. All right, so we're good. This should implement what we have documented. Now, whether or not it actually works is that's another question. So how are we gonna test this out? All right, in order to test this bad boy, let's add the functionality to the assembler to, output or assemble NOP instructions. So I'm going to create a new template for a new type of instruction. I'm going to call them simple instruction. Basically, an instruction that has a single fixed opcode, doesn't encode any parameters. So we'll just call this one opcode, not the domain, the entire opcode. Got to go class, simple instruction. So we'll call this one simp instruction template. Because I know you guys, you kids and your simps, you love to simp. So, it should be pretty simple. Static assert opcode, blah, blah. Doesn't matter really, does it? Virtual void process. So simple instruction isn't going to have any kind of parameters or anything. So process params, that's not going to be a thing. But let's just copy and paste this code. We might be able to salvage some of it. And copy and pasting it's never come to bite us in the ass before, has it? It's always gone well. So public virtual void process. I mean, if I'm going to follow, proper C++ guidelines, I guess, style guidelines, just remove the virtual from these guys and whatever. I won't do it for all of them. I'm not going to waste everyone's time here, especially not mine. Fixing up some style issues. Maybe one day, if I'm feeling it. So, we want to extract token white rest. Mnemonic rest. All right. So, there should be nothing after the mnemonic, right? So where's the thing that checks for garbage? It extracts token white, and if garbage has value. So we want to do that. I believe we want to do that. So let's just check for garbage after mnemonic. Assembling instruction, blah, at line. What is this garbage? Fair enough. So that's usable already. Now we still need the stuff that actually outputs the instruction. So we'll go back to standard instruction template, and that's probably going to be in process params. So we emit the opcode byte, and that's it. That's all we need to do. So we just go here, emit, emit. I love this naming convention. It's really done good this time. We just emit the opcode, and that's it, because it is a simp. It does not have anything else except for the opcode itself. So there you go. We've added a simp instruction template. Now let's add an instruction to the actual assembler. We'll go to assembler.cpp. We will go register instruction simp instruction template. B 00. I think it was 101,000. Let me make sure. This is the time for double checking if ever there was. Yes, it was correct. Haven't gone senile quite yet. And that is going to be called NAP. No, that's going to be called NOP. There you go. And something's wrong. Okay, yeah, we're missing an angle brace there. That's a problem. There you go. So we have added another instruction and a whole another template of instruction types to our assembler. We get errors? No, of course we do. Why wouldn't you ever get errors? Void process, constant override. Suppose it would be nice if we actually inherit from instructions. This is why, by the way, teachable moment here for you guys who are interested in C++. This is why override is great. It tells you when you're doing stupid shit. Like this. Yeah. Okay. Let's do it. Please just work, because this was very simple addition. It should not cause me so many problems. And indeed, it has not caused me so many problems. Let us assemble a program. This is where I'd really like to have the output from the assembler that gives you the line-by-line disassembly, but whatever. Another day, perhaps. So let's insert no ops in a whole bunch of different random places. Should not affect our program. No matter where we put these no ops. So I'm just going to put a bunch of no ops in here. And yeah, lots of no ops. And let's try to compile and see if we get any errors. If we get any exceptions. Well, we hit a breakpoint. And image successfully generated. I believe this is more bytes than we were using before, which makes a lot of sense. Let's look at the output, shall we? So mol.asm.txt, and we see, yes, 282828. So 28 is our no-op, and we're seeing lots of no-ops in the places where I would sort of expect them to be. And that's a good thing, right? That's a beautiful thing to behold. Now, the question is it going to screw us over? When we run this program, we should expect the exact same output that we would get if those no-ops were not in there. It would just, it's just going to take a little longer with the no-ops in there. So the final moment of truth. I say final, but if this doesn't work, then obviously it's not going to be final. We're going to have more work to do. Load image. Go into the ass. mol.asm.txt. We have our program in. It looks like the one that we expected. Let's make sure the clock is reset to where it should be. And yeah, let's just tick through a couple times. Let me see if I can zoom out a bit. Still retain vision of all the necessary parts. Sure. All right, so simulate tick once is Control T. So Control T. Yeah, so we're getting red here. I believe that is to be expected. Considering that we're perhaps enabling this. Well, what is blue again? I forget what blue is. I feel like blue is maybe undefined or something like that. I don't know. I should probably know this. But anyways, from the things that I set up, I would expect perhaps F to be in conflict with this D here. Control T, let's move on. So we moved here. It almost looks like we skipped an address. I feel like things aren't working like they should be. You know what? Okay. So things are looking weird for sure. We've probably got issues. Let's just reset. No. Let's reset. No. I guess I need this one. Let's reset. Yeah. Okay. That's good. All right. So what we're going to do is we are going to set some values here to be multiplied. Again, very simple. 3 times 2. Nothing could be simpler. do believe the first two are the inputs and the last two are the output. So we'll close this window. And I say we just let her rip. We just let her rip and we see what happens. Simulate tick frequency is at 16 hertz. Tick's enabled. Let's go. Let's just do it. All right, so it's going crazy. And it looks like it has reached the infinite loop here. Infinite loop is working properly with the NOPs. That's not an issue. But I feel like it took less time than it's supposed to take. I'm just going to say that. So we're going to disable the ticks. We're going to look into the memory here. And yeah, that's not the right answer. That's not even close. So now comes the fun part. What did I miss? What did I mess up? Did I wire something up wrong? Was my original idea of the control bits wrong? I kind of played fast and loose with some of those control bits. Maybe that was the issue. I don't know. That's the fun part of debugging. Who knows? Who cares? I guess I care. But I wish I didn't. All right. So 28, my boy, my beautiful, beautiful boy. It's probably not a good thing to get a bunch of blue, because I'm pretty sure blue means you're screwed. Maybe. I mean, it doesn't matter, does it? So Control T, Control T. See, why does it skip there? Because it's not loading. So this one maybe is incrementing. That's what I don't get. Let's reset again. Bring me back. We're gonna go back. So you load the opcode to 8. Interesting that this thing does not get cleared. It should probably be cleared. It's important that we clear that, I feel. So where is the clearing thing? Yeah, that's right there. That should also apply to this bad boy here. There's no reason for this to... I mean, probably it shouldn't matter if everything is working properly, but still. You want to start off on a clean slate. You don't want to have, you know, hysteresis or whatever you want to call it, memory from the previous iteration hanging out here. We want to start off in a fixed state for all of these latches and registers. So, Control T. All right. So that was, I believe we were getting that skip there because this started off with a 28 in it. That's just it's an issue for me. You know what I'm saying? That's an issue. So we get an increment here. Do Control T. Increment. Counter is enabled here. So it's going to double pump this thing. But why? Why is it double pumping? That's what I want to know. Because it shouldn't, right? Because this is enabled. And this is what? This is 16? Where's our freaking instruction? Okay, this is probably backwards, first of all, which is bad. What is even driving our buses? Nothing is driving the bus. Nobody is driving the bus. Okay, so problem one. This is backwards. Number one problem. Besides anything else, I'm just looking at this. I have some misgivings about this double pumping on the first instruction when nothing's in here, because this is going to be. I have misgivings. Is all I want to say here. But we'll forget about the misgivings. Let's fix what we know to be wrong for sure, which is this garbage. So, negate, yes. So the yeses should be no's and the no's should be yeses, is what I'm trying to say. No means yes. Don't take that out of context. Please don't. Okay, here we go. All right, now this is enabled, which is good, because that's the thing that should be enabled. Let us reset everything. Okay, so you're mad. You're mad because you're bad. If you're bad, then I'm your dad. Why does this look weird? Why are you the way you are, Logisim? I just want to ask that question. Why are you the way that you are? Ah, because we got this wire hanging out here. Yeah, because we didn't want to do that. Oh, that's interesting. God damn it, Logisim. Just let me... Oh, God. Okay, well... No! That was not what I wanted to do. Oh... You know, I'm starting to remember... Starting to get this, like, little inkling feeling of remembrance. Why there wasn't any videos in this series for so long. I'm like, I love doing digital logic stuff. I love it. No, there's a reason. No! Tried to sneak your freak ass. Okay. Alright. That probably wasn't necessary. I just wanted to do it because, you know, reasons. Okay. So you are blue for some reason. Blue, dabba dee dabba die. What? That makes sense. They're all 0, right? Everything is 0. Now that's the thing that worries me. If everything is 0, this thing is automatically determined to be a counter boy. You know what I mean? Probably don't know what I mean. I don't even know if I know what I mean. But let's press Control T anyways. Control T. So this moved to 1, but this one does not say 1. Why? Control T, Control T, Control T, Control T. Okay. Okay. So this is bad. This is pretty bad. So the thing is, guys, before, when we were starting off, we always started off with a 0, 0 instruction, which was nice because we also start off with 0, 0 in here. Now that we're not doing that, I feel like we have some problems. Like, why isn't 28 being loaded into here when I tick? So this is not being, well, no, Q is enabled. What is this line here? I believe this is set to 1. D into here is no good. It's no bueno, right? Q comes into here. That enables, that turns this off. So I do Control T. We get a 28 in here. That's good, right? That's good. That means that this is activated. This thing drives the bus. This thing drives the line here. This one, the bus is now being driven by this. So far, so good, right? Why? Adrix select is 0. That's going to be a problem. It appears as though 0, 0, 0 is probably not a good value here. I mean, that's why we're not seeing anything happening here on the address bus. But it shouldn't matter, right? Because by hitting this line high, that is going to reset the phase, or reset the, phase reset. And that means that that is going to enable this operation for the first half of the clock. So this should increment. Control T. Now we get an error on the address select. Why is that? I mean, that's an interesting. So you're driving it at the same time you're driving it. Ah, yeah. Okay, well, that's a dumb thing. That's easy to fix. That is trivial to fix. My bad. Obviously, you have to only drive the bus when you're given the license to drive the bus. And that comes from here. This is your license to drive the bus. So here is a signal to say that it's our turn to be the driver, and here's a signal to say that we have our driver's license, and then we do that. All right. So we just have too many bus drivers. This guy's trying to drive the bus at the same time as the other guy, and that's not good. Reset. Let's try it again. Control T. Control T. Yeah. I mean, this is dumb. It looks dumb because it looks like we're accessing this memory when really we're not. But that's just because we put 000 in the address select. We do this one. We do this one. 24. Load the value. All right, this seems to be working. I mean, I think it looks like it's working anyways. So let's simulate. Ticks enabled. And we will try. It might be working. Let's simulate. Disable the ticks. Edit the contents. E8. Okay. So it's not working. Wait a minute. I did not fix these inputs before I tried again. So, one more time. We're gonna clear. And we are going to run it. Ticks enabled. Okay. Ticks out for Harambe. This is gonna work. I have the utmost confidence. All right, it appears that we have entered the infinite loop, crossing the fingers. 06. So our no op is a go op. One thing I want to fix, again, I understand where old Chili is coming from. It doesn't matter. These are don't cares. At the same time, I'd rather it just put the instruction pointer there, because then it won't jump around so much when it's tracing through the memory. You know what I mean? In this thing here, it's always going to jump back to address 0. We don't want it to do that. That's annoying. So that means that we're going to have to change our encoding here. It's not going to be quite as sexy, whatever you want to call it. So what is it going to be? That's the question. Why do you always freaking deselect? That's the other question. So I guess I should have looked at this a little closely. All right, so there's one bit that's not set, and then there's one bit that is set. So that means that this should be a 4. So if my calculations are correct, we would like this 0 to instead be a 4. Save that. All right. Second moment of truth. One more time. We're just going to reset this for good luck. And Control K. Whoops. Why did that happen? What did I do? Simulate. Control K. It's Control T. Wrong button. I pressed the wrong button. Also, that does not seem to be... well, it does seem to be the correct answer when you consider that this has already been 0. So if we set this back to 2, and we set this one back to 0. All right. And then we reset this. Lovely. And then we do Control T. Yeah. Control T. Again, Control T. Control T. Control T. Yeah. All right, so this is what we want to be doing. All right, so now it doesn't jump around so much when we're stepping through the program in memory. A little easier to follow. Beautiful. So I think that's it. We have improved our assembler here. We've added to its corpus, whatever you want to call it, its dictionary. And we've added this very simple instruction here. Let me just see if I can't save a little bit of space. Change our... No, we should do this. Yeah. And then if I move this down a little bit. Yeah, that's looking nicer. Beautiful. All right, so there's our NOP instruction. It took longer than I expected, but I guess that's to be expected since it's been a few years since I've actually dug into this circuitry and added a new instruction. But there you have it. In the next video, hopefully now we'll be able to get down to the dirty business of adding some more variations on our move. We want to be able to move from indirect immediate into register and move from register into indirect immediate. So those are going to be, I think Bad Boy's probably going to put them down here. I'm going to have to expand the size of our circuit canvas here. But yeah, look forward to it in the future. Until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button. Helps a lot. And I will see you soon with some more chili pork unit.